Okay, let's go ahead and get started. Hi, everyone. Thank you for joining today's webinar with the topic, How is Digital Subsurface Utility Mapping Changing the Industry? My name is Trevor Brown, and I'm also joined by Ryan Pierson from Juniper Systems. He's our Utilities and Public Services Manager. So during this webinar, if you do have questions, please do write them in the GoToMeeting chat dialog, and we'll be sure to follow up with those questions after this webinar. Okay, we have a lot to cover, and we're going to go ahead and get started, and we're really going to target about 30 minutes so that we can allow everyone to get back to their day. All right, here's the agenda for today. We're going to start with a brief introduction of Juniper Systems. We're then going to discuss some utility locating and mapping challenges. We're also going to discuss briefly GPS accuracy and provide an explanation on how it applies to this webinar. We're going to do a brief overview of Juniper Systems GPS hardware. And then for the majority of the webinar, we're going to focus on several practical GPS mapping software options and just talk about some of the benefits of each of those and how those can be applied for utility subsurface locating. We're going to follow up and allow for folks to write some additional questions, and we will make this webinar available online as a recorded session, as well as in a PowerPoint format if you need it. All right, Juniper Systems. We are a US-based designer and manufacturer of ultra-rugged field data collection equipment. We consider ourselves field data collection experts, and particularly in kind of harsh environments, anywhere where it may be hot, used outside, wet, cold, dusty, humid, those types of environments, and often our users are professionals in collecting data. And our parent company is also located here in the US, and they are Campbell Scientific. They are one of the world's largest manufacturers of stationary data loggers, so they focus more on stationary data collection. Our factories are located here in Logan, Utah, which is in the far northern part of Utah in the mountains next to the Idaho border. So we do provide all support directly from our factory here, as well as through our many great dealers and partners. All right, this slide is just meant to represent that we are a relatively small company. We have about 150 people, but we do have a pretty broad reach. As I mentioned, our primary headquarters and factory is here in Logan, Utah. We do have additional offices in the UK, Kansas City, as well as in Austria. But we are supported through a partner and dealer network around the world. And so we are a relatively small company, but we do have a pretty broad reach. All right, so we just wanted to bring up some topics related to current utility locating and mapping challenges. Now, the first that many of our customers are aware of is that, after utilities are located, that paint wears away and the flags do disappear. That's a pretty common issue that causes utilities to be relocated regularly. Definitely another challenge is that after utilities are located, if mapping is required for those located utilities, it can be quite expensive to hire a professional surveyor to come out and map those utilities, and coordination with that surveyor takes time as well. So that is a pretty common approach. Utilities get located, and then a surveyor has to come out and map those utilities after the fact, and only then can the total job deliverable be provided to customers. All right, another common challenge is that, in order to get that survey equipment, it can be quite expensive, and a lot of the techniques and software used with that survey equipment can be complex and quite expensive. So that's a pretty common challenges that a lot of our customers face as well. And finally, a lot of data being recorded related to those utilities is recorded on paper, and there's a number of challenges that can be introduced when you're recording information on paper. It can be lost or wrecked somehow, and often data is recorded in non-standard ways. But then ultimately, it has to be put into a digital format, so it causes some data entry as well as migrating to other systems like geographic information systems or CAD systems, for example. So it can be hard to kind of translate from paper to a digital format back in the office after utilities have been located. You know, and then one of the biggest challenges of all is this picture I took right outside of my window as we were building our new factory. You know, if utilities are not located correctly, or if they're not mapped and made available to, you know, excavators, for example, you run into some problems. And so this definitely can trigger a number of issues and expense and time. And so this is what we're trying to avoid for sure. All right, we wanted to kind of do a brief explanation of GPS accuracy and how it pertains to this webinar. This is a really common question and one of the most common we receive here at Juniper Systems when we're talking about GPS. So there's a number of ways to communicate GPS accuracy, and it all really relates to statistics. So there's different measures of and ways to communicate it. So for example, you see, you know, a common way that GPS manufacturers communicate their accuracy is circle error precision, so CEP up there. And what that's saying is that they communicate a GPS accuracy. So for example, if they say sub-meter accuracy or less than 3 feet, if they're talking in terms of statistics in circle error precision, they could be stating that it only happens 50% of the time you will get a result that is less than sub-meter. That's a very common way for GPS manufacturers to communicate GPS accuracy and how accurate their GPS receivers are. Here at Juniper Systems, we like to communicate GPS accuracy with very high confidence. So, you know, we hold ourselves to the kind of 2D RMS standard, or 2 sigma, which is a 95 to 98% confidence. And we do that through both independent internal testing as well as independent testing from other users as well. So the focus of this webinar, when we're talking accuracy, we really are talking, you know, according to the national standard for spatial data accuracy. And we use those same test methodologies and communicate that with a high level of confidence. All right, so when the customers call in and they want to know about GPS accuracy, of course, every customer would like to have the highest accurate GPS as possible. But with higher accuracy comes in potential for increased complexity in the techniques that you use to achieve that accuracy, but also an increase in cost. So really, it's important to make sure that your GPS accuracy is aligned with the type of job that you're trying to do. You know, you see here on the left, there's a cell phone being used, and a pretty common accuracy of a phone or consumer type device is about that 5 to 10 meter range. So really about 15 to 30 feet. And that's perfectly great for certain jobs like navigation around, kind of seeing your general position, navigation in a car, for example, those types of things. That's a perfectly great solution for that type of job that you're doing. Another job is this kind of range in the 1 to 2 foot, you know, or 30 to 60 centimeter range. So for a lot of utility applications, this is good enough for what you're trying to do. You know, we kind of think in some situations it's about the size of an, you know, or smaller than the size of an excavation bucket. So if somebody had to go and dig, you know, depending on the situation, this 30 to 60 centimeter range is really quite good and helps users find and relocate utilities that were buried, for example. However, there's other jobs and other requirements where the less than 10 centimeters or less than 4-inch type accuracy is really a necessity. You know, so for certain utilities, and especially, you know, if you were you know, had some requirement or you're getting ready to build for construction, you know, these types of professional survey grade accuracy is certainly required. The focus of today's webinar is really going to be in this 30 to 60 centimeter range or sub-meter accurate. All right, we're going to quickly talk about our Juniper Systems GPS hardware and in our mobile devices, and just to represent what types of equipment can be used to achieve that sub-meter accuracy. So the product that has been extremely popular for Juniper Systems right now is our Geode sub-meter GPS receiver. So I wanted to give an introduction here. It is a sub-meter accurate GPS receiver. It allows you to collect and achieve sub-meter accuracy in real time. So you don't need to do special techniques later. You simply turn on their GPS receiver, let it sit for a little while, and you will start achieving sub-meter results. It's a very affordable receiver as well. So it truly is one of the least, if not the least cost, truly sub-meter GPS receiver that is available today. And it is an all-in-one receiver. So your GPS receiver as well as your antenna is all inside of the enclosure that you see there. You don't have extra cables or different things like that. So it is it does have a compact size, so it's easy to transport and use. And it does have an open interface. It's meant to work with a number of different mobile devices. So it's not restricted to only Juniper Systems devices. And in many cases, our customers are using it with their own phones that they already own. It does have a long battery life. Here at Juniper Systems, we make sure that all our devices last a full workday, as well as it's built Juniper rugged, like all of our other devices here at our factory. We make sure these things can be submersed in water, they can be dropped. We really want to try to minimize any kind of concern related to, working with these in a harsh environment. And then our main goal was also just to make it really easy to use. We really wanted this product to be able to bring high accuracy to a lot of professionals in a lot of different industries, including the utility locate type industry. So currently this product runs it's compatible with Windows 10 devices, Windows mobile devices, Android, and in the very near future, we are expecting it to be compatible with Apple iOS type devices. We do have an active project to complete that, and we expect that to be available this spring. All right, just to kind of talk about, some basic tests that we've done just to kind of demonstrate the accuracy of this device. We do have we have multiple professionally surveyed locations out here at our factory. Here you have a guy that's kind of just taking some points and comparing, and then ultimately we compare that against the actual surveyed position. The little yellow dot you see there is the true surveyed position, and you see the Geode captured positions all landing within the 1 meter radius in a very tight cluster as well. So that's a very good result. You see that same result at the other corners where we were doing our testing. And here's a little bit different depiction of that same data and information. This foot here, or this circle you see here is actually just a 1 foot radius circle. And you see the points landing in a very tight cluster within that 1 foot radius. And down there below, when if you look at the data, here's an example of how GPS accuracy can communicate it in different ways. If we hold ourselves to the NSSDA standards of 95% confidence, we see we're very confident that you would achieve 0.5 meter accuracy 95% of the time is what that's stating. So what you see is that a lot of the majority of the positions are landing well within that sub-meter range in the 1 foot accurate range. Now there are there is a way that you can increase the accuracy of the Geode through post-processing. It takes a little bit involved technique, but basically you take your field collected data, and then there's a software tool that you use in the office to run your data through that software tool, and then it will export your data in a refined accuracy, and we typically see about just over 10 centimeter accuracy once we post-process that data from a Geode. And that green box you see there, it represents the physical size of the Geode receiver itself. That's kind of a good way to kind of depict how accurate that receiver is. All right, here's some common ways to carry the GPS for utilities type applications. So we know a lot of folks in the utilities industry, they're not always working with just subsurface utilities locating. They also work with aerial assets and different types of utility inspections, for example. So this Geode really is a versatile tool that can be used for a wide range of GPS utility mapping type applications. You know, you see on the left there are some shoulder mount options. That's a very common one because it's kind of low profile. It allows you to just clamp that Geode directly to a backpack, and we see very negligible accuracy differences when carrying the GPS in that way. There are backpack options that exist as well, and this is kind of a nice one as well. You can just put that pole right in a backpack and be on your way and mapping. The one on the right is very common as well, is just putting the Geode on a survey pole, and that way you can have your data collector attached to that same survey pole and use it for mapping. And then finally, this one is very common, is you can just put that Geode onto our smartphone tray. So your smartphone tray fits into a little attachment, and the Geode attaches to the top of that, so you can kind of carry it around in a pretty convenient way. All right, now we're going to get to the majority of our webinar, and I'm going to start with handing it over to Ryan Pierson, our Utilities and Public Services Account Manager, and we're going to talk about several practical GPS mapping software options and provide a brief introduction for those. Certainly we can be available to provide more in-depth explanation of how they can work and how they can be applied to your specific situation and which may be the best for your scenario. So I'm going to go ahead and turn it over to Ryan to introduce the first software that we're going to discuss today.
Thank you, Trevor. I appreciate that. Just to reemphasize what Trevor has stated, the Geode receiver is performing tremendously for many of our customers who require good accuracy, the ability to work with different software applications and different handheld devices, and to do it very simply at a low cost. What we're talking about today are some practical software applications that will be a benefit to underground location professionals, those who locate utilities using professional tools and a way to create maps using the Geode with an appropriate field device and application software. I'll be introducing the collector application for ArcGIS from a company called Esri. We'll start here and then we'll talk about these other software options. The advantage of the Esri collector application is that it is a component of the Esri ArcGIS environment. For some of you on the call today, you may be an existing Esri customer. Using the collector application is a very nice way to map underground utilities that have been located. Go ahead and proceed to the next slide, Trevor. So just to kind of summarize the Esri collector app for ArcGIS, number one, this is an extension or a set of tools that are specific to the Esri ArcGIS environment. This means that if you're an Esri customer, these tools are made available to you and you're able to load these onto a phone or a tablet, the software application, and go out and accurately map underground utilities when it's paired with our Geode receiver or similar. The advantage of the Esri collector app is that it is highly configurable. It does support Windows operating system, Windows 10, Android operating systems, and Apple devices as well. The collector application is designed to be a office to field and back solution By that I mean there's data that may reside in a database at the office that you want to carry with you to the field. The collector app allows you to view data in real time from a server, such as aerial photography, existing utilities that have been marked already. Property lines, for example, may be accessible to you in the field. In the field, you would then collect new information about utilities that may be marked, and then that is synced back to the office. The collector application does allow you to map points and lines with attributes, so not just a point or a line on the map, but you're able to identify it as a vault, for example, or a meter valve, or a hydrant valve, or a hydrant. There's attributes, descriptive information that can be tied to the points that you're collecting. It is part of an enterprise GIS. The collector application only works with the Esri enterprise GIS. The collector application also doesn't integrate directly with locators. So we'll talk more about that. Some of these software solutions will communicate and record data from your underground locate equipment. Others do not. The collector application does not. So what's the workflow? Go ahead and go to the next slide, Trevor. The typical workflow for the collector application is simply to do your marking, going out and painting the utility location or placing flags. Once the locating is done, you would then come back with the Geode paired to your field device running the collector application and map the as marked or as built utilities that you've marked on the ground. You would record not only the location, the points and the lines, but also enter attributes similar to what you see on the screenshots to the right. It does allow you to attach photos and documents. You're able to sync the map data back to the Esri ArcGIS database. There's a very simple workflow to the field and back to the office using these customized forms. It's a very simple solution that's easy to deploy. Does require some management on the IT side to support this, but once it's configured, it's very simple. This does require you to first mark the underground utilities and then map using the collector for ArcGIS tools. Does require a field PC, an accurate GNS receiver, and a locator. It's important that as we go through and talk about these software applications that you choose the one that's most appropriate for your workflow and for the resources you have available. If you're an Esri customer, then the ArcGIS solutions would be a good choice, the collector for ArcGIS application. I'll turn the time back over to Trevor to talk about some of our other software options available for locating underground utilities. Thanks.
Okay, thanks, Ryan. All right, the next one that we'd like to discuss is different from Esri Collector in the sense that this software can run standalone on your mobile device. So you have a process where you collect data with your mobile device, and then you can export your data into file formats that you can utilize in different ways and share those files with different types of applications or different customers. So what's very unique about this application is that it's called Pointman Locate. It's from a company called ProStar GeoCorp. They're based in Colorado. And this software, it allows you to pair directly with your locate device. So you pair both your locate device and the GPS within the software. So you can basically map while you're locating at the same time. That's really kind of a unique solution that you typically don't see in these other options. The other options are going to be more similar to what Ryan described, where you locate your utilities and the things you want to map first, and then you so you may have to spray paint or put stakes or find them, and then you create the map. where in this case you're pairing directly to the locate device and your GPS, and so you're mapping while you're locating. And then the best part too is that it's very easy to use. I mean, it's very simple. You don't have to be a mapping professional to learn how to use it and to come up to speed very quickly. It does work on Android. I do understand that Apple will be supported in the not too distant future. From a price perspective, there is an annual fee for it, but it's definitely reasonable for the types of jobs and the value that it's bringing. All right, so how this software works, like we discussed, you pair your Geode receiver. So you see how there on the left, you have your GPS receiver on that guy's shoulder. That's paired to the mobile device. Your locate device is also paired within the software on the mobile device. Once you're all paired up, you simply just start locating utilities like you would normally. And as you push the button, positions and information is being recorded directly on your mobile device. Once you are ready, you can then just simply share that data with other customers. And so, common ways that's done are through Dropbox, Google Drive, or just export of files such as CSV, so Excel, shape files, KML, and even PDF as well. Those can then be viewed in a GIS system. Even things like Google Earth, are commonly used. And you would see all of your locate statistics such as depth, frequency, current, as well as all your GPS information and statistics, that give you an understanding of how accurate your GPS position is. On the next slide here, there's really, just a re-explanation of the different components that you need for this software. So you do need a Geode receiver, a high accuracy receiver, as well as you have to select a mobile device. So we have, two good options here at Juniper Systems. We have our Mesa 2 as well as our Cedar Android line, which works great with this software. Or you can use your own Android device as well. Once you do that, you run the Pointman software on the application, and then ultimately you do need a locate device. Some of the most common that we see are the radio detection locate devices. Those seem to be very popular in the industry with this software. And here's some simple screenshots of Pointman locate. It's really, on the left you have, it's a very simple user interface. You simply push the new button up at the top right, and that's going to launch this little pop-up. You select the type of utility that you're locating, which will then kind of guide you to, it will then, result in a line or a point, depending on the type of utility that you select. You then see the map and information that you've mapped and the utilities you've mapped on your device. And once you're ready and mapped all the different utilities, you then just send that job or share that job in a number of different file formats like I described earlier. And that, you can email it to yourself, or like I mentioned earlier, you can save it to things like Dropbox and then share it with your customers, or import it to your CAD system or GIS system. I always want to kind of give a shout out to our partner at Subsurface Solutions. He has a great YouTube video here. Again, this link and all of the presentation material will be made available, but Travis Brown at Subsurface Solutions was really kind of instrumental in helping to promote this solution with his radio detection customers and locate devices, and they have a lot of successful users able to locate and improve their locate workflows using this software and the Geode receiver. All right. Next, the next one that I wanted to discuss, it's from a company called Effigis in Montreal, and we've known them for a long time, and they make a software called EZTag. That's what runs on your mobile device, and then they have an office post-processing software called EZSurv. This category of mapping software, I would say, is more in the advanced GIS features. There's a lot of features that you can utilize for mapping points, polygons, lines, setting up custom data dictionaries to enter data when you're mapping those. And then the post-processing feature really allows you to gain the highest accuracy possible. That's really where we were looking at that sort of 10 centimeter type accuracy once you post-process. It does run on the Windows platform, so it works great with our Mesa 2. And even though it's an advanced GIS features, and it does take, there is a steeper learning curve to get up and running with this. It really is, one of my preferred tools. Once you get up and learn how to use it, it really has a lot of functionality and works really great. So let's look at kind of a quick summary of how that works. This really is an alternative to some of the Trimble alternatives that are out there. So for those of you familiar with Trimble, they have TerraSync and Pathfinder Office. EZTag and EZSurv are really alternatives to those software. And when you combine that with our hardware, you have, it really ends up costing, about half to a third of the price of those Trimble alternatives. And we feel that the solution, is really competitive compared to the results that Trimble gives you as well. In this type of workflow, you really have a process where you plan your project, you collect your field data, you post-process your field data, and then you upload your data to a GIS. So we'll quickly kind of review how that all works. You essentially, when you plan your project, this is where you can create a custom data dictionary that allows your users to enter custom information about each of the types of things that you're mapping. And this will guide, so as they map something, they'll be guided through a little series of questions that you set up in advance. You can load base maps and different types of high resolution maps if those are available, and you can put shape files as layers onto your device as well. So if you have parcel maps or different types of maps from the county, those can all be loaded as layers so your field workers would see those. Then, when you're collecting your data, it's then just a matter of users select the type of thing they're mapping, and it will, they would select it, and then it would guide them through a series of questions, and then you would see those features loaded onto a map. Once you've collected your field data back at the office, this software looks very complex, and it can be because it has a lot of advanced features and functionality, but for most of our users, they really just use the very simple aspects of this software. They open the software, they point to their data, so they browse to their file that was collected from the field. That's what they've done here. They then push a button, and then it kind of just does its magic. There's a lot of logic underneath the hood, and in real time, as a reminder, we were getting about 30 to 50 centimeters with that geode. And once this post-processing occurs, it happens really fast. Usually takes about 20 seconds or so once you push the button. You then get the result of about 10 centimeters, and your data is updated. And it's using a process of, it's post-processing its data where it's comparing your field collected data against terrestrial base stations that are all across the US and the world as well. So it just finds the closest base station that's set up from USGS and managed, and it compares your data against that base station source, and then corrects your data essentially. Finally, you then export your data into a number of different file formats. It has CSV, KMZ, shape files, and even a DXF option to export your data as well. All right, and the last one that we're going to cover today is one of my personal favorites that I use all the time as well. And this one is called Mapit GIS. It's available on the Google Play Store. It's super easy to use and train. It does have a lot of advanced features, and the price is just really great as well for what you get. And it works great with the Geode and runs well on both our Cedar Tree devices as well as our Juniper Systems manufactured devices. This software, here's a couple of representative screenshots of some data that was collected. So you see there on the left, this was collected with just a Samsung phone, Android phone, and you see some examples there of some handhole, manhole, riser, and a marker post that was mapped. And the way that works is all you have to do is once you've kind of set up the attributes or the information that you want to map, you then set that as your active layer, and then you just simply push the little square button on the bottom right, the little plus button, and out will pop. It says, a series of questions that you set up for yourself. You could just simply write a description if you like, but in this case, we set up a drop-down list of what it is they're mapping. So there's the different options. And then once you're done and you've mapped all the things you want to map, you then can just simply export your files to a bunch of different file formats, such as shape, CSV, or KML, and some others, and there's a DXF as well option. Similarly, you can also share those files on Dropbox or Google Drive or email those as well. This is a really great tool, for the price and what you get and the utility. It works great in connecting directly to your Geode receiver. So it's a very common software used for, mapping a lot of different types of utilities. All right, so kind of in summary, is just to circle back. So, how is digital subsurface mapping changing the utility industry? Really, what we're starting to see is we're seeing less and less paper being used, and affordable and user-friendly software is more available. Here's some great options we just shared for you. Also, high accuracy GPS is more affordable. It's more user-friendly. And this is a big change from the past, where maybe some of this type of accuracy was only kind of available through professional surveying and through a lot more expensive equipment. And finally, we're seeing some job roles change. There's less dependency on survey professionals from utility professionals. So there will always be a need for survey professionals, and there's certain jobs that absolutely require that. But for the other jobs where those different type of accuracy and techniques is not required, then a lot of what we're seeing is that utility professionals they're very capable of making their high accuracy maps and supplying that component of their job requirement to their customers as well, increasingly. If you do have questions, we really are passionate about field data collection, and we really would love to discuss your specific projects. If you have questions about or would like to get recommendations on things that we know and that have worked for others, we'd be happy to discuss and share some of our experiences and things we've learned from other customers and their projects as well. Certainly, if you are the type, if you're looking, we are a factory, and we always are actively looking for dealers, but please contact us. And if we would also be happy to put you in contact with our trusted dealers and representatives who are in your area as well. So as I mentioned before, if you do have questions, please feel free to write those in the chat dialog there at in your GoToMeeting little pop-up, and we'll be following up with you as well. And we will be following up with the presentation and make that available if you missed it or want to share that as well. So thank you for joining today's webinar, and hopefully you found it useful and have some ideas on how it could be applied to your specific jobs.